Okay, so now extracting strings, portions of strings and substrings. So you can a substring means a portion of a string, and you generally pull it out from a start location and what the end location is. You have a couple of different variations on it. You can put just the start location, and if you do that, then Java assumes you want to start with that character, but then you want everything after that. Or you can give an actual range. So again, back to here, if we were to say something like substring S1 plus HTML, which we could do. I'll do this one right here, and I will just what will we do? Let's say I think they've got S1.substring. Let's do this whole thing here. So you now got welcome to HTML. Because what we did was we looked at here and we said, well, we want to get everything up to 11. That's HTML starting with 0, ending with 11. It's exclusive, so it doesn't include 11. So 0 to 11. And then we're essentially going to concatenate HTML to the end of it. So what we get when we do that is welcome to HTML. Now a whole bunch more. You can convert them to upper and lowercase if you want. You can trim spaces on both sides if you have some extra spaces. You can replace a character with another character. Replace just the first occurrence of a string with a new string. You can replace all of them. And then you can also do something called split. We'll look at all these in a moment. Split actually takes a delimiter and will convert the string into an array based on that delimiter. Okay, so you have all these things here, to lowercase to uppercase. Probably won't go over all of them, but if you had them, you could trim them out. Replacing something with others. So for example, I could have, instead of doing this, I simply could have said S1.replace first, probably. Let's see. Java with HTML, and that would have done the same thing. So essentially, replace first would have done exactly the same thing. If we look at it, we should get welcome to HTML both times. You can replace just a single character. So I could also come and say what do we want to say? Replace E with, and we'll just make it an uppercase E, and it has to be a character, so it's a single quote. So now you see that it basically capitalized all the letter E's in there. Basically is what it did. And you can change different things. You can change one letter with multiple letters and all that sort of thing. Tokens, you can split something if you want. Um, in this particular case, we have Java HTML Perl.split on the pound sign, and that will give you an array. Creates an array based on each one of these will be a row in the array, and then you can print that out. Seen a lot of these. Let's start. And you get it there. Now we can also put an LN, which is a new line, in there. So it puts each one on a different line. Matches, you can do a match, replace, or split a string by specifying a pattern, which they call a pattern, or known as a regular expression. Saying one string literal matches another is equivalent to saying it equals. So we're not doing any sort of pattern on it. But you can also do a pattern as well using wildcards like an asterisk. So we can try each one of these. And you can see it comes back true in both times. It's doing a pattern match. If we didn't have the asterisk there, which is the pattern, it wouldn't work. It comes back false. And the asterisk just means a zero or many characters. Just look for a match on that. And there's all kinds of wildcards here that you can have. All first split methods can all be used with regular expressions. And a regular expression means that you're defining a pattern or a template to match on. And you can do that. Usually, when you see the patterns that are inside brackets, that means to change any of those occurrences with that. So the plus sign would be replaced with 3 N's, and $sign, and all those things would be replaced. If you wanted to do tokens based on different things, and then you can split it on any one of those, it looks like it's almost any character. So this is the same example as before, but now what we're going to do is, instead of doing it like that, it's going to split it on a dot, comma, colon, semicolon, or question mark. And it'll give us the same output. Okay, a bunch of methods in for strings, and again, you can find out all those methods simply by saying s1 dot, and it'll just drop down and give it to you. And you can see there's a whole bunch of them. Some you'll use more commonly than others. So index will find out if a particular character exists in the string. It'll find the index of that. You can look for the index of a character or a string, and you can also look at it for it in a substring by putting an index, a from and to index. You can look from the back, instead of from the front of the string, you can look from the back, going in the opposite direction, the last index of. And again, you have the option of characters or strings, and also just looking in a subset of the string. And again, we have a whole bunch of stuff here. Sure, this is all going to be... let's see. And we get all those values just as they're showing the 0, -1, 9. And this because W is at the 0 location. There it is. X returns -1 because there is no X in there. So that's almost like a sentinel value, a -1. And O returns 9 because it found it at the 9th character, and so forth. And then going backwards, the last index of A returns 14 because it's at the end. Oh, so the string also provides several static, or usually these are helper utility methods for converting from one type to another. They usually have value of, and then you can give different arguments for it. And usually it's overloaded, you just pass something in. So this is to convert that value, in this case 5.44 would be a double, to a string, to convert it to a string. Of course, you have other options as well. You can just concatenate an empty string to the value, and that will work as well. And we've got this Paladine program. Let's take a look at it. I got it somewhere. Check Paladine. Let's see what this one does. It asks you to enter a string, and then checks to see if it's a Paladine. Paladine, I believe, means that it's spelled the same front and backwards, going frontwards and going backwards. I believe that's what a paladine means. If I'm not mistaken. Um, so let's see if that's see if I've got the right recollection or not. So if I enter just my name, all lowercase, B-O-B, if I'm right, that should be a paladine. And it is a paladine. Okay, good. I was right. If I run it again, and this time I'll say Baba with an uppercase B, it's not a paladine. It wouldn't be because it's case sensitive. So think of some other paladines you could have. So this is something that's spelled exactly the same way, forwards and backwards, including case. Words that are naturally paladized. Level! Very good. Level. And yes, it's a paladine. I'm impressed that I remember what a paladine was. And something that's not. Say, race car. Wow, guys are good. So it is a paladine. Very good. And of course, hello would not be, so it's not a paladine. So that's what this thing does here. And what it looks like to me is it's using a while loop. It says while low is less than high, it's going to compare the character at low to the character at high. And it's going to increment the low by 1 and decrement the high by 1. Could have done this with a for loop too, by the way. And that actually makes sense because it compares 0 to the last character, then 1 to the second to last, and so forth. And if in any case they're not equal, then it's not a paladine. And that's using the char app. You also have a bunch of helpers for other things as well. You can actually create a character class if you want to. And the character class has a bunch of helpers as well, which could be useful. So you should distinguish between the character primitive type and the character class or object. They hold the same value, but one's a primitive type with no methods or anything like that, just raw data, and the other is a smart data type that not only has the value of a character, but also provides you with a lot of functionality as well. So the character class has that as well, and some of it could be definitely useful if you're parsing data. Digit would obviously be any numeric value or digit. A letter would be just a character. Letter or digit would be like an alphanumeric. Whether it's lowercase or uppercase, you can also convert it to upper and lower. Much like the string can do that stuff, but it does it just on a single character. So again, we could do this and put this into our string test here.